Hey, I'm Daniel. Really excited to talk to you about building a card game with pygame. And for this, we're going to learn some Euchre. So this is Euchre. There's normally four people. They sit across from each other. And I'm going to be calling these positions north, south, east, and west because they're kind of like sitting across from each other. Uh, it uses a normal deck of cards, but it takes out most of the cards and has a 24 card deck. So there's only nines, tens, jacks, queens, and kings in the deck. Um, so there's something also called a trump suit. So that is like other card games.
It's not like a royal flush equivalent.
It's not really like a royal flush. It's just something that someone can say is the trump suit and it's the highest. And so what that does is actually changes the card order. So the jack of the trump suit becomes the highest value card, and the jack of the diamonds here becomes the second most. So like, yeah, the jack from the other suit actually goes into the trump suit, which is like that's kind of like the most confusing part.
Yeah.
Which is a little. It's like what?
How do you code the logic for that?
Yeah, so we're gonna show that. And those are the jack of the trump suit and the jack of the other same color. It's called the right bower and the left bower. So um, those are a couple of terms. Uh, so what you there's like a up card that the dealer starts with, and it'll be like one of the cards in this deck, and then you get to decide like, yes, I would like that to be the trump card, and you bid on it. It's called bidding, or you pass and let someone else go around and say, oh, would they want to get it? So you kind of take turns deciding what this trump suit's going to be. Uh, the score is first to 10. You play tricks. So the way this works is like if the trump suit is hearts, then the dealer will go first and put their say highest heart if they had one, or another card. And if they don't play the trump suit, then that is the lead card, and then everyone has to try to get the highest of that, or someone could play a trump, and then that person takes it's called takes the trick, and you score points uh, taking the trick or not. And I can show it in the game as well, like how it kind of works. But it's effectively, yeah, like big things. There's four players, they're on teams, and this weird like trump suit reordering of bowers, I think, are like the key things. And then it's like trying to get the highest cards and take a trick. So, all right. Uh, Also, the calling team, which is the team that uh, said they wanted the trump, they bid on that trump. They need to get three tricks to score, which is, yeah, win three times. If they win all five, then they get 2 points. And if they don't win, if they get like two or less, then that's what Euchre is called, and then the other team gets 2 points. So that's kind of like how the scoring works. All right, I know that's a little confusing, but we'll see it in action in a bit. All right, so I want to talk a little bit of like architecture because we're building a game. I think it's really easy to build like an imperative game where it's just like, if this happens, then do that, or like get this input from the user, and if that happens, do that. For a game like a card game that does, we just said like card suits reorder mid game, and there's game states where things are like bidding and stuff. So they kind of look simple. Maybe Euchre doesn't sound simple, but until you start building it, then it becomes really complicated. And then like every new feature you try to add breaks kind of unrelated code. And so I wanted to like talk about, hey, how do we architect a card game to make sure kind of the presentation of the game, the core logic, and like our data of like what's allowed when is kind of separated. And so we're gonna create a boundary, and pygame will just be one part of that boundary, and we'll see that in a second. So this is like, hey, you're the human player. This game is meant for you to play with three bots, so it's not like a multiplayer game we're building here, but you can imagine you could make a multiplayer, but we're playing against three bots. One's your teammate, and there's two people against you, right? And so there's these four things, and once again, your player is like the south position of the four players. Okay, so let's build an architecture. This is called a component view of the architecture we want to build. And first, let's start on the right-hand side. So this is a domain model. And this defines things like what our cards are, what suits exist, what are players, and all the other mechanics of the game. And then we have this rules engine, and that's in the middle. And it is what controls the transitions between states of the game and holds the state itself. So phase of the game, legality of moves, like turn order, when a hand ends, all that stuff lives in the game engine. And the rules engine queries the domain model to get card behavior and determine if cards are playable. And finally, we add a presentation layer, and this for this we're using pygame, but you could use something else, and it's pretty, with this architecture, we could easily put something else there instead,
you
right?
could use like the Django or Flask.
Yeah, you can make an app out of it, a web app or a CLI card game if you want to. And so in this case, our presentation needs to know things like window size, card images, fonts, because we're using pygame, so it's going to look like a card game, right? Mouse coordinates, like delays for the bots on how quickly they move, status messages like such and such player played an ace of spades. And then apply, we have this method. So this, I talked about these ports here. So there's legal actions and legal cards and apply. And so apply is what the rules engine uses. It's like the mutation point where it changes from, and it's the one interface it has. And so the presentation submits actions through this apply, and the engine validates and runs that phase of the game, and then reads its state, reads the presentation, what's being displayed from the presentation. And then this legal actions, legal cards is like what the presentation queries to know, hey, it would be nice if your cards dim the ones that you aren't allowed to play, right? Stuff like that. Otherwise, it's like you're just clicking on cards. You don't know what you can actually play at time and stuff like that, right? So we have this legal actions, and then legal cards is all the actions for the cards, right? All right, so that's like an architecture. So let's jump into each one. So that we talked about that domain model, it's the one on the right-hand side. So I'm using a feature in Python. I started with Python 3.4 called enum, which stands for enumeration.
That's how you declare enums.
Yep. So these are enumeration types. Python hasn't always had that, right? It's just in Python 3 that this is a new thing. These beat strings, because we can define a nine is always a 9, because you can then call rank.9 and it just means something, and you don't have to like check if strings are equal to other strings and stuff like that. And what we can also do on the right hand side, we have our cards types, right? So you have clubs and diamonds, but we can also add a little bit of functionality. We just said that like, oh, the cards change meanings a bit. Well, we can add a method to this class called Bower Partner. And what this is doing is creating a little same color dictionary. So it's checking if for clubs and spades, if they're that, then they match up, or if it's diamonds and hearts, then they match up, right? Because they're the same colors. And so then we can return the next. So this is like a generator suite for suite in the same color if it's not the current suite you're in. So if like your instance of this class is clubs, then you would return spades from that, which would be like the Bower partner would be spades. And so we use that because then we need to make sure that Jack is the Bower partner of the Jack, right? So we added a little functionality onto the definition of the domain, and then the game state doesn't have to worry about that in the rules. It's just part of what the card definitions are, which is pretty nice because you could imagine, like, I don't know, you could use a different card type to represent Bowers as well. All right, so we also use another relatively new Python 3.7 feature called a data class. And this is just a nice way to create a class without the boilerplate. So normally you have to do like dunder init method in your class and define all the things.
Question, is this an equivalent to a static class in the Java? In the sense that it's like you don't have to declare an instance of the method or instance of the class to put the method in.
So the question in the room is this the same as a static class in Java? I think it's I haven't studied Java in like 20 years, but I think it's a little bit different. So under the hood, this is just a regular class. It's just removes a bunch of boilerplate from having to and Java has lots of boilerplate as well, of having to redefine like, oh, this is the dunder init method and all these parameters. And instead you just add this decorator to the class. So you would, from data classes, import data class, and then you add this decorator, this add data class on your class, and then you don't have to create all those boilerplate methods. You can just say suit is suit type, and rank is rank type. And remember, suit and rank are the enums that we just defined before, right? And we can also add methods to this is a class like any other class, so we can add methods to it. And the effective suit is once again like, hey, if you're a jack and your suite is the bower partner of the trump suite, then you want to return the trump suite as your suite. Otherwise, you want your normal suite. So like you're like this is switching you to the whatever the trump is if you're the same color. Effective rank is the same thing. Like if your rank is a jack and your suite's the bower partner, then you're the left bower. If your suite's the trump suite, then you're the right bower. So this is on the card though, so we're defining this functionality on the card itself. And then once again, the game doesn't have to worry about that. All right, this is another example for a data class. So these are like, we define who a player is. So they have a name, a seat position, a list of cards. And once again, there's that card type. We track if they're a human player or not. This is also an interesting thing from a data class that it provides. So like this tricks taken here is an optional field. And if you had just passed in like an empty list to it, then you'd get this empty list. But we actually want, it says default factory is a list. So every time a new player is created, it gets its own tricks taken list that gets generated. So that's kind of like a nice thing, the data class that it like generates its a tricks taken automatically for you. So you don't have to, once again, create a normal class again or something like that. Yeah, so, and that's important because you wouldn't want players to share which tricks they've taken. It would be broken, right? And then a play gets both a player and a card. So what that person put on the table for that play. So those are the types of like data models we use. This is one more example for our data classes, and we are actually tracking if a play is a winner or not on the trick class here. So a trick has things like, here's all the plays that were in the trick. Remember, everyone puts 4 cards down. That's like a trick, whether someone won or not. What the trump suit was, the lead suit means whoever put the first card was whatever card that was. And that's important because if no one plays trumps, then the highest of that suit wins. So if you put like spades down, that's the lead suit. And if no one plays the trump suit, then you're gonna win. You win if you have the highest of that. So that's what this winner is just looking for. So it says highest card from trump suit wins, and that's the first part. So it's checking for a play or play in all the plays. If the card is the effective suit is the trump, so if it equals a trump class, then we return the max value of all those cards that were in that trump class. And then the highest suit that was led by the dealer wins if it's not the trump, right? So then we do the same thing. We look for all plays, or every play and plays. And if the play is an effective suit of trump equals this lead suit, then we return the max of all the other cards that were not the trump ones, right? And all that logic, once again, is on the trick itself. So like the trick knows what the highest one was.
Dumb question, but like the style of the game, is it when folks start the game, you said there's a dealer, so and there's two folks across from each other who are teammates. So is it that each person gets a set, or is it for like kind of comparing it to another game? How are the cards, the 24 cards distributed across the rounds?
So each person will have like 5 cards in their hand.
Okay.
It's actually like a weird dealing system where the dealer deals 3 cards at once to each player, and then 2 cards at once to each player,
What?
which is kind of unusual because normally it's like single card dealing.
Yeah.
And then after for the next rounds, then each player gets an extra card and then discards one.
Okay.
So
Okay.
yep. Cool. Layer 2. So we talked about our data model, how we say like these are all the components of the game, and I think it's really cool to start like the game design with that. Like here's all the objects I'm going to use. Now we're going to go into like the game engine, and this is like the rules we need to apply. Once again, I'm using data classes here. They seem to be very, very useful to do things kind of like in a simple way, right? So we're going to create these things called actions, and these are the, we want the same like serializable, testable, loggable things in the game on the engine. And so these are the like transitions, the actions that apply that move you from like one state of the game to the other. So I guess the pass actions actually shared by a few things like dealing, resolving, scoring is all this kind of like pass action. But like, hey, if it's time to discard, a discard action gets sent, and then based on what's happening in the presentation layer, and then that's what actually like transitions the state machine into the next state. And let's talk a little bit more about the state machine. It's actually the real state machine is a little bit more complex than this, but I didn't want to go crazy showing something with like too many states. But in general, there's, hey, we need a deal. We need to bid on what the trump suit is. If everyone passes on the trump suit, then we deal again. Once we've picked a trump suit, then we play the game, and we score based on what people played, and then we do the next hand and deal that again, right? And then once one team has 10 points, then it's game over. So the way we do this, there's this, once again, this is the rules API, and we implement this in a central location, and there's this thing called legal actions, and that's what I'm showing here. And so this is also really nice that we use the enums, because we have like things like phase of the game as an enum, right? And I'm using like this match case syntax, which is also pretty new in Python. You could use if else statements as well. It's pretty similar, but all we're saying like, hey, we're looking at the game phase, and if the phase is dealing, then we do this thing. If the phase is playing, we do this thing, right? And you can see all the return is always this action. So we'll say we play a discard action, is the return from legal actions, right? So we're checking if the action's legal based on what phase of the game we're in, and then we return the action that results in that. And so like the legal actions is one interface again. The apply is how the presentation then applies that change to the game state. So that's the other interface. And then this matching kind of drives both of these, right? So yeah, and I see Deanne, you're posting links to data classes and match statements. So thanks for the head in chat. That's awesome. All right. So testable core. This is the most complex test that I came up with. But because the presentation is independent, we can just test the core itself and make sure like the game state changes we're expecting work. And so you can write, this is with PyTest, but you can write tests like set up the test. Hey, what is the Trump suit? Who are the players? We created just 2 players for this, a leader and a follower player. I guess we have a couple cards. We gave the follower a couple cards. We play a trick with those. So play a couple cards, and then we set up a game state with how everything is, and we're checking that the playable cards equals hearts in this case because the Trump suit is hearts. And so like we're actually testing all the game state, all of the data classes in a test, and it looks a little complex, but it has nothing to do with like the presentation of it, right? So we can test that the game's working properly without actually any presentation layer. Okay, and then this is how we now we're into like this layer 3. So this is now getting in the presentation layer. So we have a game loop. This is how you initialize pygame. So you call pygame.init. You need to create a screen, and you set the width and height of the screen. And we also set a caption called Euchre, and that shows up in the title bar. Pygame runs things on a clock, and it has ticks. So every time you want to show something or wait some time or something to happen, you use these ticks. And you'll also see down here, we like get the number of ticks. So Pygame's like tracking the time in the game. And that's how you make things like reproducible, because if it was just based on like CPU cycles or something, maybe the game would like speed up and slow down while you're playing or something like that, right?
Yeah, not good.
Yep. We create this thing called a renderer, and I'll talk a little bit about that in a second, how we do rendering. And so we create a game. This pass action, once again, this is our way to like start something happening. So when we start the game, we want to get our state machine to transition. So we send this pass action to start the game and start dealing and stuff. And then, of course, we need like a while true statement to get the main loop going. So we run while true for pygame to go. And once again, we're checking states. We get a states, the pygame states, and we're looking for things like pygame has built-in quit. So if you quit the game, that's what gets called, and that pygame gets that events, right? And then we can check if the game is not over, and if it's a human turn, for example, and then we can handle the events, this event handler with pygame to actually like render the next thing that we have. So this is like kind of like what the main loop looks like for our pygame to actually like run the display.
Handle event is embedded with the pygame.
So this is like a helper function that I created, but it's taking like pygame's event system and calling like a rendering of the layout.
Was that shown?
I haven't shown it, but in a little bit I'll show all the code, and we can look at like what the event handler and stuff looks like. I did not want to go through all the code because it's like 1,200 lines, and you guys are going to go to sleep.
Yeah.
What is this?
That's gonna be too confusing for like an hour.
Yep. All right. So I created the simplest bots known to man, which I think is great for trying something out. So how our bot chooses an action is they use the random choice it's built into Python, and looks at like, once again, it has the interface from the game to what the legal actions are. So it randomly chooses a legal choice in the game, and that's what the bot does. And actually, from playing with it, you don't actually, maybe I'm just really bad at Euchre, but I'm not like, oh man, this bot is really dumb or something like that. It seems just like I'm playing a game. So we do have this game core engine though. You could imagine if you wanted to create a smarter bot, that it would be very easy to run machine learning or AI model against the core engine and create something very smart. Probably, yeah.
Much smarter than this.
Yeah, much smarter. If you wanted to do something like that. So, but because we have this abstraction that the game engine doesn't depend on the presentation, that's also an advantage. You could actually let a computer run through the game engine over and over and over again, right?
Nice.
And we gave the bot silly names from, yeah.
Hey, Porygon.
And this is Johnny 5 here. So, okay. this is the input pattern. So once again, we're in this presentation later, we're using lots of data classes to model things. So this card hit is keeping track of the hit spot for where a mouse would click for a card, because this is part of the presentation layer. So it knows what the card is. It knows what this pygame rectangle is, where the hit spot is, and stores that with itself. And then this one also has an enabled, because some of them, if it's not a valid card to select, you can actually disable the card, right? So it can't be clicked on in the presentation layer. And then same thing, there's buttons like to pass or bid on things. And we do the same thing for that. And then there's something called a layout that we keep as well. And that's important because it's kind of like this bridge between drawing on the screen and clicking on things. And this render decides where things appear on the screen. And the input needs to ask, did the click land on something we drew? And what does that mean as an in-game action? And so kind of this layout provides those two things, which is the hand of cards with this list of card hits that you could click on, and then the buttons. And normally there's like a couple buttons that come up. And once again, we're using this default factory to create these empty lists in there as well. Okay. This is how the render, this is an example of the render. So we use those data classes in the render to draw the different parts of the screen. And so I called the card hand for the south player, the south hand. So we want to draw these cards that you, the player, has in their hand. So the way we do that is we get the human hand cards. Those are the cards you have, and there's a helper function for that. We check if which cards are legal plays that can be played right now. And they are selectable if you're in a phase where it's your turn to actually play, because the bots are going to be playing their hands as well, and you can't be clicking on the cards when the bots are playing, right? And so if it's your turn, then they become selectable. And then we go through those cards in your hands, and we actually draw rectangles using this pygame rect. And this is the left part, this start X plus the index plus the card width plus the card gap. That's like the left side of the card. The height, which is Y. I didn't show all the Y and X calculations here for brevity, but and then the card width and height. So we're drawing a rectangle around the card. We enable the card if it's selectable and the card's a legal play for you to make. And then we actually draw the cards. So we have a function to draw on the surface the card, what it looks like, using the image of the card that we've saved. And then we add this card hit zone to your hand cards, which are part of the layout. So that's how we like draw and keep track of like, oh, the human has these things in their hand. These are all the hit places they could select on. These are the ones on and stuff like that.
So beyond that, it would just be I guess a demo, we'll get to it. So I was, you just have a PNG or something for that card.
Mm-hmm, yep.
This is you adding interactability.
Yeah.
Okay.
Yeah.
Cool.
Yeah, exactly.
Oh boy, here it comes.
Oh, a demo. All right. So is this large? I don't know if it's large enough for y'all, but I'm
Yep,
just going
good for us.
I'm gonna just
Thank you.
install this. And then we can run Euchre. And this is what it looks like. So yeah, so this is like the main window. Once again, south, north, east, west players. I'm on the team with Bender here. And Robbie the Robot and Johnny 5 are playing against us. You can see like all the cards are grayed out-ish right now, and they'll get brighter in a second. And there's a pass or I can select that I want hearts as the trump card. Hearts isn't bad for me because I have other hearts here. I don't have the highest ones though, so let's go ahead and pass. Okay, so the trump is hearts. Johnny Five played a jack of clubs here, so we can choose play anything. So I'm going to choose to play the trump suit because hopefully I'll win some tricks like that. Probably someone online is gonna be like, "What are you doing? You don't know how to play euchre." So this means that I got the trick. So like I had the highest card. All the players kind of played a little fast, and we're probably not that good at this, but like I was the only one to play the trump suits, and I ended up getting that. So that's good for us. I can keep going and keep playing trump suit. Oh.
Do you play because you won first? Or do you have that?
Yeah, because I had won the last trick. And if you notice, Johnny Five played the left bower, the jack of diamonds, and the reason why that was the reason why it had like the gold around it. It was trying to show like, oh, this is actually the trump suit.
Oh,
So
okay.
draw that on to help a little bit. You can see like the trump suit was played. I have a heart. So that was the lead card. I have a heart. I have to play that. And you can see the other cards aren't valid moves. So they kind of became gray. So if I try to click on these, there is no hit spot on those cards, right? So I can play the 9. And Johnny Five took another trick from us. And I have to play the diamond here. Bender got it. My buddy.
Yeah.
All right. And I have to play my last card. Bender got 2. And we actually got 2 points there, which is cool because the other team picked the trump suit. And so they had to get 3. Otherwise, what just happened was euchre. So we got 2 points for it, right? So you can kind of see how it's kind of confusing, I know, of a game. Like, what is this game? It's very Michigan thing to play. There's also something, if you has scored 9 points, there's something like time to open the barn, and you put your fingers like this, and then your other player has to like milk your thumbs. So that's also very Michigan. Yeah. Yes. What's that?
As the program like virtual thing.
I have not programmed milking fingers. No.
That's the.
Yeah, that's got to come up next, right? All right. All right. So that was the demo. You can kind of see like how our state machine, how our cards, everything kind of like came together with a presentation to do that a bit. I think the key takeaways are of like, hey, if you set up your game, you can make any type of heart spades type game very similar to this because it would be we just change some of the numerations almost, and you probably have a very similar game. With this architecture of separating that domain, the rules, and the presentation, I think it works really nice for like an architecture of a game. There's also creating these simple APIs between the different architecture places. So like we use these legal actions to check if an action can be done, and that changes the presentation. And then applying changes to the rules engine, I think is really nice. Maybe I know we're kind of out of time, but I guess this is what I'll show the link here in a second, but this is like what the game overall looks like. So we go to the cards one here. Minimize this. This is where all those enumerations are set. Some of them we looked at, not all of them. Some of the data classes for cards and players are in this cards module. This client has, once again, this main loop that we went through, and this is how you initialize pygame. And this is also where our AI is, our random choice AI. Our AI, our bot. And then in game here, this is what has kind of some of the things from the state machine. So that defines the phases of the game, these actions we talked about, has things for playable cards and stuff like that, right? So this is all based on kind of what we discussed. And then the presentation's all in this UI section. We looked at the render. So this is once again like how we draw things with this render class. And we look, if we go down here, there's a draw south hand somewhere. South hand. That's part of that what we looked at right there. But we would need to draw what the up card is, draw the trick when it gets collected, kind of like all the different parts have little draw functions here.
And the underscore means this is a private function.
Yeah.
So what's the public that calls kind of?
So we can like click on this and see that it's just used by the class draw here.
Okay.
They probably don't necessarily need to be private because like this isn't some like public API I'm providing anyway. But
helps for readability though.
yeah. There's a module that gets the card images, and those are stored in this assets. So like 9 of clubs looks like that. So and so that's kind of what puts that there. There's an input section. There was a question before about handle event. So this gets those pygame events and the game state and the layout. And this is like looking at, hey, if the event type does not equal mouse button, or if it's not turn, return, right? So this is like looking at the game phase and looking at the input from the user to check the event states. And then finally, there's a text handling things to show the different texts that we display. So there's like a couple functions for that. I guess I didn't go super deep into pygame, but this could have been like any pygame thing. CLI could have been a web app, could have been anything because the presentation is kind of separate in a way. So you can definitely do that as a separate thing as long as you have like the interfaces set up. And we talked about tests just for a second. So there are tests that just import the
unit tests or
yeah, they are kind of like unit test. Well, I don't think they're really like unit tests because we're not like testing each function we created. They're more of like, hey, does the game actions work? They're more like some type of integration test or something, or like game engine test. Like, hey, does this game actually work properly? Type of test. So, so those are the tests there. Okay, that's maybe like a quick flyover of like what the code looks like. And there's also, you can go to the GitHub Yeaw/Euchre if you want to look at the source code and play around with it.
Maybe I can add you on GitHub.
Yeah, add me on GitHub. That's fun. Does anyone have any questions about anything?
Well, you want to ask my question?
Yeah, sorry, I missed your question before.
What was your inspiration, or what like prompted you to want to make a card game with pygames?
So the question was, what prompted me to want to make a card game? So I've used pygame a little bit before, and it's always kind of like fun creating little games and stuff. The main inspiration was I didn't have a speaker to give a talk, and I was like, what would be fun and be Michigan related? And oh, hey, I don't know how to play euchre. Maybe I'll use this as a chance to learn euchre a bit. So that was like the main inspiration, just something like fun and Michigan related. And also wanted to, you could tell I'm like interested in like software architecture and stuff as well. Like,
that was some kind of a similar inspiration for me with Go. It was like, it was a cool game. It was like, I think it was 2016, the first bot managed to beat the world champion, and I just thought it was a really cool game, and I wanted to not only learn, you know, basic that stuff, but also learn about like unit testing, WebSockets, stuff like that.
Yeah, no, that's awesome. Yeah.
How long did this take you to code, if I can ask? Or how long was the project?
I did this in the last like week or so. So yeah. Yeah.
What makes this a Michigan game?
So I have to be careful on what I bring up on the internet, maybe.
Oh,
Yeah.
don't share screen for that first.
Yeah.
Oh no.
Card games.
Oh no.
Card
Don't want to
games
get
by
it opening
state.
the barns, you know.
Yeah. So this is like of that MGM thing, but this is like an example. This is a very unique thing about the United States. Is like, I'm from California, and it says the most popular thing is it AC/DC? Is that right?
Delaware.
But
Tough color.
yeah, the color coding is a little tough, but you can say like Michigan, Ohio, we're in Euchre country. And if I since living here, people have definitely asked me if I know how to play euchre before. So it does seem to be a true thing, but it is interesting that like I don't know, yeah, I think different states play spades, or I think Crazy Eight seems to be pretty popular across some states. So this is like a very US thing where different states kind of have like regional card games that are more popular. And sorry, I think I stopped sharing, and this is what I was showing on the screen. Sorry, people online. Yeah, Nick said this is great for people trying to learn euchre.
That's correct.
I was told you could only learn euchre by playing it, and I wasn't allowed to play it until I learned to play it.
How did you manage to learn the rules of euchre for the project? Did you actually play euchre?
I have never played euchre with real folks besides watching a couple YouTube videos and like coding the game. So I was trying
your bots a bit though.
I've played a few rounds like that, so I kind of get how it works. I tried to get my wife and kids to play with me, and they're like, "Nope, we're not going to do it." So
Yeah, I can get anyone. Well, a friend of mine tried playing Go. We couldn't get it either.
Yeah.
So I've only really learned from actually seeing people play it on videos.
nice, yeah.
What's the design pattern? I know a couple of names for like MVC or like what. So what's this one? Do you have it specifically?
So I think like in architectural designs, this is often called like a hexagonal, which is kind of like a weird design name.
Yeah.
And it's because the core of the architecture is in the middle, and it shows like the things it connects to on like the outside. There's also like other names for a very similar thing.
Okay.
I think
Model view center. I've heard that before.
so that's very like the like model view controller MVC type stuff is also very like common for like web design stuff and for other architectures. I don't think this is quite that, but it does have similarities, of course, because like yeah, there's yeah, having your data in one place, having kind of like a state or some type of like logic in a place,
Yeah.
and having a presentation in a place is very similar. I think the patterns are maybe a little bit different for like a web design type thing though. Yeah, but they're very close. So
What new Python feature did you say? Because you mentioned a couple. What did you feel like you got the most mileage out of? That you were like, I will use this.
you can see like everywhere I use data classes.
Yeah.
And I wasn't actually familiar with those. Yeah, the question was like, what new Python feature did I make use of? And I think the data classes I use like heavily, and also yeah, we use enums as well, which I think are also very nice.
Switch case was really cool. I didn't know that was in Python.
Yep.
Yeah.
Yeah. So the
Switch cases are nice, but they're kind of rare to use
yeah,
because they're so restrictive.
yeah. So there's not that many places where some type of switch case is nice. I think this is like a very nice case statement of like, oh, if you're in this phase and this happens, do this, and then do this, and this, do this, right? It's kind of like models that state machine very nice, I think. So.
Yeah, it's like